So Toki is a IBC light client bridge using T's and ZK proofs. Currently, you guys are connected from Ethereum to Binance Smart Chain and are expanding. You guys use a interesting multi-prover model, so that's T's plus ZK proofs for light client bridging. So introduce us to what is Toki?
Yep. So, first of all, myself, I'm Daik, founder of Toki, and I founded this Toki maybe more than 2 years ago. And Toki is ultimate vision is to establish the internet of blockchains, which resonate the Cosmos vision. However, we are expanding the IBC visions beyond the Cosmos ecosystem, including Ethereum, BNB, or other EVM blockchains, even Solana or enterprise-grade blockchains like Hyperledger Besu or something like that. And of course, on top of that, we also have the bridge applications. So, long story short, we are building the internet of the blockchains as well as liquidity-based bridge on top of the IBC messaging layer. So this is what we are doing.
And I guess so Sumo, was I say it?
Yes.
Introduce yourself.
Yeah. My name is Susumu. I joined this enterprise blockchain and Web3 space like 5 years from now, and I contributed to Toki since the beginning. I think that my experience is a bit shorter to the most of the listeners of this podcast, but yeah, I'd like to answer as much as I can.
Okay, so Toki is, I think, let's get into the technicals first. So it is a TE and ZK proof multi-prover IBC bridge. Is that correct?
Correct. Of course, technically speaking, so Toki consists of 3 layers. The first layer is the light client with multi-prover system. And the second layer is the IBC modules, which is messaging layer. On top of that, we have the liquidity-proof bridge applications. So we are building those of 3 layers.
So to be precise, right now Toki is TEE model,
Yeah.
but our vision is to enhance it to multi-prover model, utilizing ZKPs. But right now we use TEEs for IBC verification in the messaging layer.
Actually, first of all, is why did you guys choose IBC in the first place? Why not make a Toki specific Toki specific protocol, or like use a different bridging protocol? Why IBC in the first place?
That's a great question. So we've been contributing to IBC more than maybe 3 to 4 years. We've developed the IBC Solidity, which is IBC modules written in Solidity, and we've developed a lot of light clients for various blockchains since 2021 or maybe even earlier. And why we chose IBC as our message layer? This is because IBC is the only truly open and neutral protocol that other protocol doesn't have. Which means IBC doesn't have tokens. IBC doesn't have business model. IBC has a comprehensive standard so that any developer can contribute to it. So this is the very important aspect as a open and neutral protocols for the entire blockchain universe. That's why we chose the IBC is the best as a standard or standard protocols for the entire blockchain universe to connect all blockchains. This is the biggest reason.
So can you talk about the chains that you guys are connected to? So from my understanding, it's Ethereum and Binance, right?
Yep, correct. So as the launch partner blockchains, we chose the BNB and Ethereum. This is because Ethereum is obvious, right? So this is the largest TVL blockchain, and on the other hand, BNB also still has one of the top TVL blockchains, maybe second or third TVL blockchain. And also, it was BNB and Ethereum is suitable to developing the light clients. So that's why we chose the BNB and Ethereum would be the best partner as the initial step. However, of course, we are expanding this IBC-based bridge to the other EVM-based blockchains, and the next step would be the OP stack. So yeah.
So let me add some thoughts upon that. I think I will mention this a minute later, but for applying light client model in Ethereum there are several problems to solve. One is that it's very gas expensive chain, so we need some solution for that, and I think our LCP fits into that space. So that's why we apply the Ethereum as the first launch blockchain.
Yeah.
And so for right now, it's just EVM chains, and right now you guys are just directly connecting Ethereum L1 to Binance Smart Chain. Is there there isn't like a Toki chain, right? There isn't a Cosmos chain or a Toki rollup or anything like that. Talk about the channels and connections and the process of building the IBC EVM bridge.
All right. Some projects introduces like hub chain, like Axela, but we think that there are several problems for that because the security of hub chain governed by the TVL of that chain. So we need more secure method to connect chains to enable the large quantity transfers, things like that. So not so we don't introduce the hub chain. We just introduce the IBC layers for each of the blockchains. So so those who are familiar with IBC, it's I think you are probably know this, but we have the IBC tower layer, which consists of the light client and channel and connection, and these are purely smart contract on source and destination chain and nothing else. So that simplicity is, I think, the true beauty of IBC. So there is, there is an intermediary relayer, but you don't have to put trust on that entity. Anyone can run the relayer. It's completely permissionless. And if we can trust on the code, I mean, source code of the IBC tower layer, and everyone can see within the source chain and destination chain to make sure that it behaves honest like client, make sure that they are not malicious. And yeah, on top of these light client channel connection, there are apps, IBC apps. So the Daiki mentioned, the up layer of Toki, which is basically liquidity pool. So the important thing here is that if we can trust on the source code or smart contract of these modules, then you don't have to trust. You don't have to trust any other third party. That's the idea. So in a hub chain model, you need to trust hub chain itself.
Yeah, let me add a little bit. So we would like to establish app-to-app connections or app chain to app chain connections, like Cosmos. Each Cosmos zone can establish connections with other app chains, without any big hub, right? So this is the beauty of the IBC. This is the beauty, or this is what we must achieve as the internet of blockchains. And in order to do so, as Susumu-san said, we don't need help. And in order to establish the direct connections in between, we need IBC smart contract, IBC modules as a smart contract on both source and destination chain, and we implement it as a pure 100% IBC compliant modules, and any app chain or any applications can establish connection channels without permissionlessly on their own. So this is what we would like to do.
Can you talk about the process of actually verifying on Ethereum to Binance? Sort of, you guys talked about how it's very expensive, how you guys need to use TEs, and talk about that proving process to verify the chains.
Yeah,
great question.
That's a great question, and I need to get into a bit of details here. So in pure IBC, you have a light client on both ends. So destination chain's light client verifies the source chain's consensus, and if it verified, then it accepts that information as a new block header. But as I mentioned, applying IBC in a pure way to Ethereum, you have to have the hundreds of millions of gas to verify the Cosmos chains, for example. So we introduced and add LCP, which stands for Light Client Proxy, to this model. And LCP use TEE, Trusted Execution Environment, for its safety. So TEE is, to put simply, it's encrypted computer, and internal operations and memories, external operators and attackers cannot access these type of information. So that if we run the light client within the TEE node, which means the LCP, we can rely on that it behaves honestly. So that's the idea of applying a TEE and LCP for this model. So if we think about the BNB to Ethereum transfer, the BNB's block header first is verified within the LCP. There is a light client inside the LCP within the safe zone of the processor. And once it verifies, it puts the signature with the secret key within the LCP that no one can access. And on-chain light client of LCP on the Ethereum side verifies the signature of the LCP and make sure that it is verified by LCP. Through this process, we can make sure that once Ethereum accepts the new height block header of BNB, this one is actually verified through the light client within the safe zone, within the safe processor, and make sure that it is actually happen in the BNB side.
Can you talk about the trust assumptions and then the future use of ZKPs in the multi-prover model?
Mm-hmm. Okay. There, I think three aspects to consider. First of all, you need to trust the light client smart contract, which is run in LCP. The second thing is that you need to trust the chip maker, like Intel, that Intel doesn't put the backdoor in the TEE. The third one is that I will mention it in a minute, but we run the DCAP, which verifies the integrity of LCP node, which is run by data center providers like Microsoft. So if you can think that Intel or Microsoft or other gigantic corporation are malicious and to prevent Toki's operation, I think you can basically safe to say that the whole process is secure. And to add a bit of information here, to be fair, there are several vulnerabilities found within the TEE. But I think there are no actual financial damage caused by the real hacks for the TEE system. So I think it's safe to say that our model is very secure. And the second one, the use of ZKP. So we recently released a ZK DCAP, which is a ZK model to make the DCAP attestation verification. So here is a bit of complex process here, but we have the LCP using the TEE. But who ensure the integrity of LCP node? So there are way of doing so, and it is in the end of life, but Intel is a sole provider of attestation of the integrity of LCP before this April. But we can use DCAP attestation instead, which is run by data center providers. So this is basically the chip LCP's node report its integrity to data center attestation provider, and data center attestation provider signs this report and provided it as a quote. So the third party verifies this quote to make sure that the integrity of the LCP is kept. But this process, again, is very gas expensive if you done it on-chain. So we make the ZK circuit for this to reduce the gas cost of verifying the DCAP quote. So so we release this as an open source, and anyone can use it for the same purpose to prove the T's integrity on chain. But okay, let me add some future plans of applying ZKP. So this is right now we are applying ZKP for DCAP attestation. But we are thinking further on that usage of the ZKP. So I've said that current T has not been hacked, but if there is a successful attacker that can hack T, if we have the multiple T models, then T's can disagree in that case. In that context, we are planning to apply the ZKP technology for this to arbitrage for this type of dispute. So in the context of there is a disagreeing in T, one honest operator can provide the true block header and provide it with a ZKP. Then the on-chain verifier can judge who is telling truth and who is telling lie. So if T's disagree, then bridge can halt as a misbehavior. And after the honest ZKP provider provide the one honest block header, then we can safely remove the misbehaved T from the network, and we can achieve higher secure model by doing so. So it's very long answer for the one question, but yeah, that's we are planning to do.
And can you talk about the fees saved by doing this TE model, with Ethereum, sort of the performance, the latency, and then, the cost for bridging?
Yeah. So as I mentioned, if you have a direct application of IBC, it requires hundreds of millions of gas. So it's not fair to compare it to LCP model. So it's basically inexecutable. So if we turn to a ZKP model, you have the ZK proof to apply the ZK proof to on-chain verifier. So if we compare this proving process with T, there are great efficiency benefit for applying T. So I think having the prover for ZK is around minutes. The latency, is minutes. Or if you have a giant parallelism, you can achieve a second level latency. But T, we can achieve the sub-second level very easily. With one, we have, for example, one TE or multiple T's, and all the same, we can achieve the sub-second level latency for this, and it's very cheap. On the chain side, right now, update client, which is a verification of a new block header, is around 85K. And I think the gas cost required for verifying the growth 16 one block header is around 250K. So I think there are one third of cost benefit for using the TE model. So it's So Ethereum is right now very cheap, so this doesn't account for a large difference. But if um, Ethereum goes higher, then the difference get much bigger. Yeah.
And so, are there any other, I know there isn't any IBC bridges from Binance to Ethereum. Are there any other non-IBC bridges from Binance to Ethereum?
C bridge.
Like
Yeah.
any other types of bridges from Binance
Yeah.
BNB Chain to Ethereum? Oh,
Yeah.
C bridge?
Yeah, C bridge is one of the bridges to connect the BNB and Ethereum. However, it's not so much.
I
So
haven't
that
heard
was
of it.
one of the reason. Yeah, it's
Okay.
maybe a few. That was
Okay.
one of the reasons we chose the BNB and Ethereum.
Because BNB doesn't, it has a lot of TVL. It's kind of like not as popular, but it has a lot of usage, and so people always forget that BNB has like a lot of users.
Yeah.
I guess let's talk about the process of actually building a Toki and the sort of engineering challenges. So, how hard was it to implement IBC and do the LCP and TE stuff?
Yeah. The,
It requires a lot.
yeah. Years.
Yeah, but I think that there are a couple of teams working on the IBC or Light Grant. So there is Ethereum's Alter's Light Grant and Snow Bridge, which connects the Ethereum to Polkadot, or other teams like Union, Polymer, Composable Finance. I think the we have all in common challenge that building light client is very hard. So it requires to understand the consensus of target chain and make spec for actually the light client process of the to accommodate to have a right client for one chain is very hard. And also, once you finish the implementing, you need to have it audited. And there are several chain upgrade as well. So we are currently working on the Pectora upgrade on Ethereum, and our team is a bit nervous about that. So, and this will happen every time for the upgrade of chain. So this is one of the biggest challenge. So so our team making one chain's light client requires at least 3 months, and yeah, it's really hard.
Yeah. Yeah. And the what 3 months is for design and implementation basically. And as Susan said, we have to get those audited and modify it and test it. So maybe more than 3 months will be required to go to mainnet.
And also, I'd like to add here that there are several types of blockchains that make it hard to build a light client. For example, Daiki mentioned Solana, but Solana's block structures make it difficult to make the light client. So we have the idea of running full node within the TE node, which is done. For example, Flashbots use it for the different for purpose. But yeah, we are working on that as well. Since it is very hard, I think the IBC's Eureka introduced the conditional light client model. But yeah, running full node within the TEs add security to this conditional light client model.
And so you guys have full V1, so that's like the handshake and like the setting up the channels and like everything. You guys are not doing the like light V2 version. I hear that's sort of one of the big problems with implementing IBC. It's just that first initial handshake and setting up the channels. But after that, the process to actually verify the bridging is simple. Is that true, or what's your experience with that with the initial setup of IBC?
Yeah, that's a great question. So actually, we've discussed with IBC team, I mean, interchain labs about that. But the hardest part of implementing IBC is not that handshake part, but light client part, I guess.
Yeah.
So, but
10 to 9, 10 to 19 maybe.
but you are right. So IBC V2 removed some of the property of IBC Classic. So I think applying changes to LCP and making it support to IBC V2 is very easy, I guess. But if you want to add and expand the ledgers and another consensus type, then it's a completely different problem, which is bigger.
And yeah, how was it? I know Ethereum would be really hard to do that. How was it on the Binance smart chain side of things to verify the light client stuff?
Um, so for Ethereum, we use the Altair Light client, which is official, but the shortcut of kind of verifying the consensus itself. But again, having the specs for Binance Smart Chain is also very challenging for us, and it requires months of engineering, and there are a couple of upgrades here and there, so we need to follow that path as well. So it's not easy.
Could you talk about the UE relayer? Is that
Mhm.
that's the relayer that you guys built specifically for Solidity EVM, right?
Not actually. So the UE layer is actually a fork version of the Go layer, which is implemented by the Cosmos. And the reason why we forked is that we improved the architecture of Relayer, and we introduced some abstract layer within the relayer to make it easy to expand to different chains. So the Cosmos Go layer only support the Cosmos SDK's chain, but as we change the architecture of Go layer to UE layer, it can easily support the other chains, especially for the not instant finality chains like Ethereum. And yeah, it enhanced our productivity greatly to handle the heterogeneous chains.
Okay, and so now let's talk about actually using Toki. So you guys have a bridge where you guys can bridge right now from BNB to Ethereum. Right now it's just stable coins, right? And you guys are running a points program. So can you just talk about how people can actually use the bridge and farm points?
Yeah. So as Diego said, right now we are providing the bridge functionalities, which is similar to Stargate. Maybe most of the users know what Stargate works, how Stargate works. So user can swap the USDC, USDT, and ETH basically natively. But as you know, the ETH on BNB is wrapped version of ETH. So this is not native tokens, but user can swap ETH, USDC, USDC, and the stable user can swap the USDC from USDT too. So natively, basically. And this is what user can do for now. And also we provide point program with users to earn some point, and of course this point can exchange to actual Toki tokens, which is realized maybe in the near future. And this point program is pretty simple. So it consists of two functionalities, two aspects. The first one is the activities itself, transfer or pool. And the second one is loyalty points. So we have a lot of loyalty points, which are the points for testnet users along the way. Maybe we started our testnet maybe almost a year ago, and the user who joined the early at the time as a tester, they will get the testnet loyalty points. And we have the role program. So who are actively working on the Toki community or contributing to the Toki community, they will get some role. And those role holder will get another loyalty point. So this type of action point and loyalty point is the current main program and the logic to earn some points of Toki. And the activity point is pretty simple. The more you make a transactions, such as transfer between those blockchains or deposit your funds in the pool, the more you earn points. So this is the overall of the current point program. And this point program will last a year. Currently that we are running season 1, and we're gonna turn it into the season 2 after several months.
So for the information, the role program is for the activity in the Discord community. So we have Discord community, so please join. Also, we have the, as Daiki mentioned, testnet. So you can try not with your real money, but facet tokens. Then, so it's easy to understand how Toki works. And yeah, please try that.
And there's also another thing is that you guys have working with Japanese stablecoins and also sort of data chain. So can you explain sort of that use case?
Yeah. So we are Japanese, and we've been working on Japanese financial institutions a very long time, maybe more than 5 to 6 years in this sector. And as I said, we started developing the IBC or cross-chain stuff since 2020 or 2021, and at the time we talked with the MUFG, Mitsubishi Financial Group, which is the largest banking group in Japan, to realize delivery versus payment, which means security token on blockchain A and payment token on blockchain B, and we're gonna make a settlement between those blockchains using our infrastructure at the time. So we have very, very long, deep enough relationships with those top financial institutions. And the MUFG group established new joint venture called Progmat. And this joint venture or Progma is established by the several major financial institutions, including MUFG, as well as Datachain. So Datachain is one of the investors to this Progmat. And the Datachain is the core development team behind Toki too. So this is kind of triangle relationships between the financial institutions, including MUFG or Progma, Toki, and Datachain. So Datachain established this joint venture, and Toki is kind of a spin-off project out of Datachain, and Datachain is one of the core dev team behind Toki. And in this triangle, Toki will provide this BNB, Ethereum, or other even blockchains cross-chain functionalities to the Progmat. So which means Progma is the issuing their stablecoin regulated by Japanese regulation. And we're going to support that stablecoin cross-chain transfer using our core infrastructure. So it's similar to the CCTP of Circle. So USDC can burn on the source chain using CCTP and mint it on the destination chain. So we can provide similar functionalities with the Progma or stablecoin issuing platform. So maybe within this year, or hopefully, stablecoin will be issued on the multiple blockchains, and we're going to support those blockchains as for those stablecoin to enable the cross-chain transfer using IBC or our infrastructure. So this is the current effort driven by those three entities.
Mm-hmm. And just to clarify, Datachain is not a chain; it's just the group who
develops
Toki, right? Okay, just
that's right. That's right.
I want to make it clear.
That's right.
Okay,
that's right.
Anyways, so I think that was pretty good. Is there anything else that I'm missing about Toki, or anything else you guys want to talk about?
I guess that's good. So, can I talk about the passion stuff?
Yeah.
So yeah. Actually, the Susumu-san and I talked a lot in the podcast. But the long story short, we would like to establish the internet of the blockchains, as I said in the beginning. And in order to achieve these visions, we need secure, efficient, and open protocol, right? And the open and the neutral protocol is the IBC so far. And efficient and secure protocol is brought by light client with TEs or multiplier. So this is our core infrastructure to make it happen. And of course, we have to, one of the the current major utility or use cases is liquidity bridge. So that's why we established the liquidity pool on top of those core infrastructure. At the same time, we are integrating those core infrastructure with third parties, of course, like other bridges. And one of the notable the project is stablecoin issuing platform named Progma, established by Datachain and MUFG or other major financial institutions. So that's why we are traveling very long. This is very long travel to realize this vision, maybe, and the financial transitions between the traditional finance to the new digital finance will take decades or more. So we are just beginning, maybe still starting point. So that's why we have to establish the really necessary infrastructure for the cross-chain, and we are building it. So, and we're gonna bring some real use case, which is stablecoin third-party integration within this year. So it's gonna be huge use cases for IBC community as well as Cosmos community, and we're gonna take the IBC to the next level within this year. And of course, right now we support just BNB and Ethereum alongside Cosmos. We're gonna support most of the layer 1 blockchains and the layer 2 major blockchains within this year. So IBC will be everywhere in 2025. So please stay tuned and please try out Toki applications and please earn some points. So this is what we wanted to say in this podcast.
Another question I want to ask is, I was talking with you one time and you said that all the Japanese crypto founders don't really live in Japan, they live in Dubai. Can you talk about the sort of environment and regulatory environment of Japan for Web3? Sort of where are they at when it comes to adoption of crypto? And I know you just told me we're just getting started and it's going to take decades. So like where is Japan right now with crypto in general?
That's a good question. So in terms of the regulation, from the regulation perspective, the Japan is ahead of other countries. So we have the regulation for security tokens, stable coins, and other cryptocurrencies. So we have the pretty clear line of those new assets. However, the problem is, one of the biggest problem is tax, not the regulation side, tax side. So we have the very heavy tax problem. So let's say this is the tax problem is getting lighter in the past a few years. However, when I moved to Dubai, maybe 2 years ago, that was huge, because if we realize Toki token and maybe FDV will be the 100 million, in this case, the tax was imposed onto this 100 million, which means we have to pay 20 million US dollars as a tax. Of course, we don't have money, so we have to sell the tokens. Of course, the token dilution will increase and price will drop off. That's why we couldn't issue our token at the time due to the tax problem. So this was a huge problem. And but yeah, overall we have the clear regulation compared to the other countries. So and most of the technical staff and the regulation staff and the tech staff is getting better, and now we are getting ready to move forward in 2025.
Mm-hmm. Anyways,
is it clear?
Yeah. Go ahead.
For me, So as Daiki mentioned that the currently in Japan the regulation is clear, but at the same time it's very strict. So compared to other countries, the wave of crypto is very smaller. So there is no summer, but there is no winter. So, but the adoption grows steadily, I guess. So that's the one of the characteristics in Japan. You cannot see the hype, but you feel something is happening and adoption is getting bigger and bigger.
Yeah. That's good term. Strict. Clear, but strict.
Okay.
In order to get overcome those strict requirements, we took a lot of time, but now it's almost there.
And so the original plan wasn't like to do Toki, it was we want Japanese stablecoins, and then you guys needed a bridge, and then you guys were looking for what bridging protocol to use, and then decided IBC is the best bridge, and then now starting to build out that stuff. Is that like the correct order of how it happened?
Order is the stablecoin is more later stage. So we were thinking that IBC first. The other time, maybe 2020, we have the major problems in the blockchain space: scalability, interoperability, privacy, and so forth. And interoperability was one of the biggest problems, as you know. And we believe that future will be multi-chains, as we see now. So that's why interoperability was the problem. The degree of the problem of the interoperability will grow. So we thought like that at the time, 2020 or 2021. That's why we started doing some research. What would be the best solutions for interoperability, and we decided to contributing to the IBC. And after that, as we assumed, there are a few enterprises, institutions want to issue their security tokens or stablecoins on different blockchains, and we started working together with those institutions, and one of those institutions was Progmat or MUFG. So this is the right order.
Mm-hmm. Okay, I think we're now pretty good. Enjoy the conversation. I'm excited for sort of new teams to expand IBC. So I guess this is the end. Thank you so much, Daiki, Taiki, and Sosumu, for having
thank
on.
you so much.
Thank you so much. Thank you for having us.